Hi, Assalamualaikum warahmatullahi wabarakatuh. I'm going to start off with a simple example that is going to motivate our next discussion. Right, so here in this example, you are asked to find the limiting value of this function when x gets closer to 0. Well, if it exists. So, sometimes you can resort to sketching a graph in order to get the answer. So this is what I'm going to illustrate next. I'm going to show you how the knowledge of sketching graph can be useful in certain circumstances. Yeah. Okay, so let's start off with sketching the vertical axis and the horizontal axis. So this is x, this could be my fx. So the function that we have is 1 over x squared, and this is something that we have already discussed in chapter 1, and I'm sure you will see that if x is equal to 1, this is going to be equals to 1, so we have this point here. So if x is negative 1, this is also going to be equal to 1. Okay, let me just erase that a bit, I think. Okay, let me change the position of it, maybe somewhere here. So basically the graph is going to have this shape, so it gets very close to this line here. So this is the asymptote, but it doesn't touch this line. So similarly for this one here, so it is symmetric with respect to y-axis, something that you have seen in chapter 1. So it's going to be looking like this, more or less. Yeah. Okay. Okay, this is also the asymptote. It doesn't touch this axis. All right. Okay. So now just make sure that it is symmetric with respect to y-axis. Okay. So based on this, the point of interest is at point 0, and you know that it can approach 0 either from the left direction or from the right direction. Now we are going to use the definition of one-sided limit. So we can say that the limiting value of this function when x approaches 0, when x approaches 0 from the left direction is going to be equal to, well, you can see that our function is going upwards and forever extending upwards, so it's going to be equal to infinity. Okay, so for this one here, when x approaches 0 from the right direction, you will see the similar behavior where your function here is going upwards, and it will keep on continue doing that without exactly touching this y-axis. So for the second one here is limit x approaches 0 from the right direction is going to be equal to infinity. So what we can say is, we can say that the limit x approaches 0 for this function is going to be equal to infinity, but actually in this case limit doesn't exist because infinity is not a number. Our discussion or the definition of limit requires this value here to be a number. Okay, so in this case the limit doesn't exist. If you want to be specific, yes, it is the answer is infinity, but actually limit doesn't exist. All right, so now we are going to formally define the idea of infinite limits. Okay, based on the example given just now, let's talk about infinite limits. So if f is a function defined on both sides of a except possibly at a itself, so at a it is not defined, therefore the limit of this function when x approaches a is going to be equal to infinity, which means the values of the function here can be made as large as you like by taking x very close to a but not equal to a. So similarly, let f be the function defined on both sides of a except possibly at itself. Then the limit of this function when x approaches a can be equal to negative infinity. So when it equals to negative infinity, it means that the values of this function here can be made as large as possible, as large negative as possible by taking x to be very close to a but again not equal to a. So that is the definition of infinite limits. For this one is positive infinity, and for this one is negative infinity. So on this slide here there are several examples. For example, this one you can see that if x approaches a from this direction, so the values of fx is going to get arbitrarily large. Okay, so in this one you can specifically write that the limit of the function fx when x approaches a from the left direction is going to be equal to infinity. Okay, now how about this second graph here? So for this one here, you can see that x approaches a from the right direction. So for this one is the limit of this function fx when x approaches a from the right direction, so we have positive sign, is going to be equal to infinity. Okay, you can see that the value of fx is going upwards and rising. Okay, now for the third graph here, you can see that x approaches a from the left direction. So the limiting value of this function when x approaches a from the left direction is going to be equal to negative infinity. You can see the value here is going downwards. Okay, but it doesn't touch this asymptote here. Next is for this one, this is the limiting value of fx when x approaches a from the positive direction, and this is equal to negative infinity. Okay, so for this one here, this is limit of the function where x approaches a from the left direction is equal to negative infinity, and this one the limit of the function where x approaches a from the positive from the right direction, I mean, is also negative infinity, and therefore the limit of this function when x approaches a is equal to negative infinity. So this is the last part, or the conclusion, based on these two statements given here. Okay, I think that's all for now. Thank you very much for watching.